Now, Tchebycheff inequality, the statement of Tchebycheff inequality. If x is a random variable with e of x is equal to mu and variance of x is equal to sigma square, then p of x minus mu greater than or equal to c, which is less than or equal to sigma square by c square. And the alternative statement, p of modulus of x minus mu less than c, which is greater than or equal to 1 minus sigma square by c square, where c greater than 0. The alternative form of this, put c equal to, in this c is equal to k sigma, where k greater than 0. Then Tchebycheff inequality taken the form of p of x minus mu by k greater than or equal to sigma, which is less than or equal to 1 by k square, or p of x minus mu by k less than or equal to sigma, which is greater than or equal to 1 minus k square by 1 minus 1 by k square. If it is greater than or equal to k sigma, we can write either less than or equal to 1 by k square or greater than or equal to 1 minus 1 by k square. It's the form and the general statement of Tchebycheff inequality. Now the problem. A random variable x has mu is equals to 12 and a variance sigma square equal to 9. Find the unknown probability distribution, and we can find the expression of p of probability of 6 less than x less than 18. So now we have to use the Tchebycheff inequality. So by writing the formula, p of x minus mu greater than or equal to c, which is less than or equal to sigma square by c square. Suppose if you want to use this formula, now either this formula or this formula, if it is less than or equal to means sigma square by c square. If it is greater than or equal to 1 minus sigma square by c square. So this is less than or equal to, and in the same case we can use another form of Tchebycheff inequality, greater than or equal to 1 minus sigma square by c square. So now already we have modulus of x less than or equal to 1. So mod x less than or equal to 1, which is nothing but minus 1 to plus 1. So in this, modulus of x minus mu less than c is equal to minus c less than x minus mu less than c. So minus c less than x minus mu less than c, which is greater than or equal to 1 minus sigma square by c square. Now here x minus mu is there. So here minus mu is there. So we can multiply, we can add 1 plus mu on all the sides. This is plus mu minus mu can be 0, so which can be x, so that we can add 1 plus mu on both sides. So this will be mu minus c, this will be less than x less than mu plus c, which is greater than or equal to 1 minus sigma square by c square. Already given values are means mu is equal to 12 and variance sigma square equal to 9. After we substituting given mu and the sigma square in this expression, so now mu is equal to 12, so 12 minus c, p of less than x less than, here mu is equal to 12, so 12 plus c, which is greater than or equal to 1 minus, here the given value sigma square equal to 9, so 9 by c square. So till here we have the answer, and now the question, p of 6 less than x less than 18. So now randomly we have to choose the value of c equal to 6, because then only then value 12 minus 6 is equal to 6. That's the question. And also if c is equal to 6, 12 plus 6 is equal to 18, then we will be getting the question. So now after we chosen the value of 6, this is the value, and 12 minus 6 and 6, 12 plus 6 is equal to 18, which is equal to the same 6, c is equal to 6, substitute in right hand side also, 1 minus 9 by 6 square. So after taking the LCM, 6 square 36, 36 minus 9 by 6, 36. So after simplify we have 3 by 4. Hence the value of probability of 6 less than x less than 18, which is greater than or equal to 3 by 4. And then the next question. A Faraday is tossed 720 times using Tchebycheff inequality to find a lower bound for the probability of getting 100 to 146s. So now here we have to find the mu value under here. The previous question mu under sigma square values are given. So in this question there is no mu under, there is no sigma square. So now we can use the binomial distribution for this. Already we have the binomial distribution formula. Means equals to NP and variance is equal to NPQ. So first we have to find the value of NP and value of NPQ. Here the question, a Faraday is tossed 720 times. Here then n times are 720. So the die is tossed, there are 720 times. So clearly the value of n is equal to 720. And also if a Faraday is tossed, we have the probability is equal to 1 by 6 because there are 6 phases in your dice. And if one turn of probability 1 by 6, two turn of probability 1 by 6, so probability of success is 1 by 6, and q is equal to 1 minus p is equal to 5 by 6. And also there are 720 times a die is tossed, so n is equal to 720. Hence the mean of the formula we have already NP. Mean of the binomial distribution is NP. Hence NP is equals to n value is equal to 720 and p is equal to 1 by 6. So 720 by 6 is equal to 120. And we have the formula for variance is equal to npq. So npq, after we multiply the three values we have 100. So now mu mu is equals to 120 and sigma is equal to now 10 because of means equal to here NP, and therefore we have to take the value of mu is equal to, in this mu is always mean, mu is equal to mu, hence mu is equal to 120. And also sigma which is nothing but a standard deviation, square root of variance is equal to standard deviation, therefore sigma is equal to 10. Now we can use the Tchebycheff inequality. P of modulus of x minus mu less than or equal to k sigma, which is greater than or equal to 1 minus k 1 by k square. So now x minus mu, we have the mu value is equal to 120 less than or equal to k sigma. Sigma here it is 10. So less than or equal to 10 sigma, which is greater than or equal to 1 minus 1 by k square. So this is the form of x mod x less than or equal to 1. So we have the formula mod x less than or equal to 1 is equal to minus 1 less than x less than 1. So the same we can write it as minus 10k less than x minus 120 less than 10k, which is greater than or equal to 1 minus 1 by k square. So it is the value of x we have to find. Here minus 120 is there. So after we added plus 120 on all the sides, so this has to be plus 120 minus 10k less than x less than 120 plus 10k, which is greater than or equal to 1 minus 1 by k square. So this is the final steps. Now the come to the question is probability of getting 100 to 140. Hence suppose if we choose randomly k is equal to 2, this is 120 minus 10 into 2 is equal to 20. So 120 minus 20 we have 100 less than x less than, if k is equal to 2 here, 10 twos are 2 tens are 20, 20 plus 120 it is 140. So we have the question, then only we will be getting the question. So probability of 100 less than x less than 40, which is greater than or equal to, the same consider k value on right hand side also. 1 minus 1 by 2 square equal to 1 by 1 by 4. 1 minus 1 by 4. 1 minus 1 by 4 is equal to, take LCM 4. 4 minus 1 equal to 3 by 4. Therefore, this value which is greater than or equal to 3 by 4. Now in the another question, this is the discrete random variable problem. A discrete random variable x takes the values minus 1, 0, 1 with the probabilities 1 by 8, 3 by 4 and 1 by 8 respectively. Evaluate p of modulus of x minus b greater than or equal to sigma and compare with the upper bound given the Tchebycheff inequality. So from the discrete random variable, we have already formula for E of x and E of x square. We have E of x is equal to summation of sigma x into P of x, and E of x square is x square into P of x summation. So now first E of x, summation of x into P of x. So minus 1 into 1 by 4 plus 0 into 3 by 4 plus 1 into 1 by 8. So after we multiply and added these 3 is equals to 0. Now E of x square. E of x square, we have the formula summation of x square into P of x. So after we squaring the value of x square into P of x, so minus 1 whole square into 1 by 8 plus 0 square into 3 by 4 plus 1 square into 1 by 8. So after simplify, we have the answer E of x square equal to 1 by 4. Now variance of x is equal to E of x square minus E of x the whole square. So E of x square equal to 1 by 4. 1 by 4 minus 0 is equals to 1 by 4. Now P of modulus of x minus mu greater than or equal to 2 sigma, which is greater than or equal to x minus, here we have mu is equals to say E of x is equal to 0. So P of x minus 0 greater than or equal to now sigma. Sigma, which is nothing but variance of x is equal to 1 by 4. Therefore, square root of variance is equal to standard deviation, which is sigma. Therefore, square root of 1 by 4 equal to 1 by 2. So, 2 into 1 by 2 is equal to 1. Hence, P of x greater than or equal to 1. So, this is for the discrete random variable. For x greater than or equal to 1, we can take x is equal to minus 1 or x is equal to plus 1. Already we have the probability x is equal to minus 1, we have the probability P of x is equal to 1 by 8. And also for x is equal to r means it is plus. And x is equal to 1, we have the probability is equal to 1 by 8. So 1 by 8 plus 1 by 8 is equal to 1 by 4. Hence, P of x minus mu greater than or equal to k sigma. That is, this is the question, which is nothing but less than or equal to 1 by k square. This is the formula. Now, instead of k is equal to 2, because of the question is greater than or equal to 2 sigma. Hence, k is equals to 2. Therefore, k is equals to 2 less than or equal to 1 by 2 square is 1 by 4. So, which is less than or equal to 1 by 4. So, we have the answer. This is the upper bound, because the value this side only will be in decreasing. This side are always increasing. Hence, it is the upper bound, the value less than or equal to 1 by 4. Hence, prove the question.